I'm the CTO of Continuum Security, and I have a dual role. I spend most of my time doing security testing of web apps, and then I also do about 40% of the time I'm doing development work. And that was kind of the motivation to creating the BDD security framework, which is taking development tools and development techniques for testing and applying those to security. So security is playing catch-up again with development practices, in this case DevOps. And although there's a lot of hype around DevOps, I think there's a lot of real value there. And there's a lot that we as security practitioners can learn from what is happening in DevOps. I say we as security practitioners. Who's in a security role? Hands up. Who's in a development role? Good. Who is in neither of those roles? What role are you? Test architect, very good, very good. So it's good to see a good mix of the two disciplines. And what I'd like to do is frame DevOps as a means, right? It's the means to an end, but not the end in itself. DevOps gives us the ability to use continuous delivery and continuous deployment. And what continuous delivery and continuous deployment say is that instead of building our software by batching up all of our features into a release, and then taking that release and putting it through the testing process and eventually deploying it, why don't we release individual features? So as we finish a feature, we take it through the same process and we deploy it into production. This means we don't have to wait for everything to be completed before we start seeing real value from it. We can get our features into production much faster. So this kind of explains the relationship between DevOps and the development practices. If you're doing agile, vanilla agile, or continuous integration, as a developer, you're working in your restricted development environment. So you're building your code, you're building your features. Once you've built up your features into a release, you may run it on your continuous integration server, which runs automated tests on it. You say, well, this is working in development now. And you take that software, hand it over to someone else, and it's then their responsibility to build a testing environment, deploy your code into a testing environment, run more extensive tests on that code, and then eventually deploy it into production. So there's a distinct handoff process between development and ops, or development and the rest of the organization. And to do that, you don't really need DevOps. You don't need tight integration between developers and operations, because you're just doing a handover to them. But if you ramp up to continuous delivery and continuous deployment, now, because you're releasing an individual feature that has to go through quite an extensive testing process, you have to talk with ops, and you have to have more automation in the process so that you can deliver not just code, but you're delivering code plus a working testing environment that you've built through automated configuration. You're running more extensive automated testing against your new feature, and then in the case of continuous delivery, you deploy into a pre-production environment, and there's still some manual process that has to go on to deploy it into production. Or if you're doing complete continuous deployment, it takes the next logical step and says, we want one entire continuous process that will give us feature going in one side, and we deploy all the way into production on the other side. And the continuous delivery guys talk about a pipeline. So it is this one long continuous process. Your requirements go into one side. Those requirements get turned into tests. Tests get turned into code. Code gets deployed into further testing environments. Tests run against those, against that code and against those environments, and then finally deployed into production. So DevOps gives us the ability to operate that pipeline. DevOps is currently the only way we know that we can run this continuous delivery pipeline, where we're delivering code and environments all at the same time. So when dev and ops are working together in perfect harmony in a DevOps environment, you can now reach these kind of numbers, where Amazon is deploying into production every 11 seconds, a new feature into production every 11 seconds. Etsy, gov.uk, multiple times per day. So I think the question for security is quite clear, right? if we have this ability, if we can deploy at this rate, how can we do this securely? And I think the typical security team's answer would be something more along the lines of this. Forget about continuous deployment. I can offer you continuous annoyment, right? There's no way we're going to let you deploy into production every 11 seconds without doing security testing. And we simply cannot deliver security testing every 11 seconds or 25 times a day. And why is this? So this is typically how we would approach application security from a traditional standpoint. We'd have our central component are our security requirements. We derive those security requirements from organization-wide security standards and a threat model for our application. Combining those two things, we decide what controls we need in our application. Some of those controls are going to apply to ops. Other controls are going to apply to the development team. And that's usually a dead document type of operation, right? It's written in Excel or PDF or Word or something like that, handed off to developers. And I know what happens with that document. It gets thrown away or it gets put into the bottom drawer and never looked at again. So once we say dev does implement the requirements we've asked them, and so do ops, we then have our security processes which verify that we have implemented those requirements. And those are typically manual processes. For example, we have the security team who would run things like scanners, static or dynamic analysis tools. And although those tools are automated, running the tool isn't automated. It's still a human who goes and initiates an SS scan or goes and initiates an app scan, interprets the results, decides what to do with it, and then hopefully maps it back to our requirements, saying, well, these vulnerabilities now say we've not implemented these specific requirements. We would then rely on manual application security testing. So we get expert testers in, come and test our application, tell us what's wrong with it. For bonus points, we would offload some of our functional security requirements to the QA team, right? There's no need that we need specialist security knowledge there. We can get the QA guys to test some of that for us. So this model doesn't really fit into a continuous delivery pipeline. So if we want to learn from DevOps and how DevOps is doing the process, we don't have to start from scratch, because security testing is really not that special, right? We're doing testing which is very similar to what quality testers are doing. We're doing slightly different tests, different types of tests in a different way, but in essence what we're doing is quite similar. So we can look at where quality testing is currently applied in DevOps, and we can piggyback security testing on the same processes. Continuous monitoring is something else that DevOps is quite famous for, and I'm not going to go into that at all, because it's a whole topic on its own, other than to say that the OWASP App Sensor project is probably a great way to get continuous security monitoring built into your application. And then extensive automation, and particularly automated tests to verify that what you're doing is correct. And that's what I'd like to focus on next. And when I say security testing, I'm talking about more than just security scanning, right? Scanners find bugs. They find implementation flaws. But scanners don't find things like functional security. They won't tell you that a user account or that you have an account lockout on your login function and that's not working anymore, or that the captcha that you're meant to display on your self-registration page isn't being displayed anymore. Those are all functional security things that I want to test, but a scanner is not going to find it for me. Another conceptual difference is that tests have an expected outcome. Tests can pass. You give it a specific passing qualification, right? So you can assert that if this is the case, then the test passes. Otherwise, the test fails. Scanners just have a silent response, right? If a scanning result is going to be a positive response, it just gives you back nothing. Then you say, great, I got back nothing, awesome. But there's no real passing criteria built into a scanning run. And if it's a human operating the scanner, that passing criteria is stored in the human's brain. Like it's the operator saying, I've got back these results from the scanner, Some of them are important, some of them are not. I know these are false positives, and therefore, okay, this is fine to go live. I'm not going to act on these vulnerabilities. So that logic is not stored in code anywhere, and it's often not documented anywhere either. Next up, if you're doing test-driven development or behavior-driven development, then the tests can become a direct substitute for your requirements. This means you can move away from this dead document model of requirements, where your requirements are written on a piece of paper somewhere, and you have dynamic requirements, requirements that can verify themselves. So if you at any point want to know, where am I standing with my requirements? Simple, run my tests. What do my tests tell me? If any of them fail, I know those requirements are not being met. And finally, tests are treated the same way that code is treated. So they're stored in source code control. You know who changed it last. And if something breaks, you can go and track back and see who changed what at what point. So this is a first stab at writing that type of security test, right? This is a non-functional security test. We want to verify that the session ID after login is different to the session ID that you were given before login to prevent session fixation attacks. So using JUnit and Selenium, we can write something like this. So first up, Selenium, get a particular URL. Selenium, everybody familiar with it? It's a browser automation framework. It uses a real browser. You can give the browser commands and it'll go and navigate the app for you. So selenium.get a particular URL, then read the session, get the login page URL. So I'm reading the login page, I'm not logging in yet. Once I've got that page, if the app is setting a session cookie already, read that session cookie. Then log in. And how do we log in? You tell it through Selenium how to log in. Find the username field, enter the username, find the password, enter the password, click the login button, and you're logged in. Now go and read the new session cookie that has been set in the browser. And then my passing criteria. Assert that the after login session is not the same as the pre-login session. And we will then know whether our session cookie has changed. So this works, but there are a couple of problems with it, or architectural problems. The first one is that we've got two separate domains mixed up here. We've got our navigation logic for our app and our security requirement that we want the session ID changed, all mixed up in the same bit of code. So changing the session ID after login is a common requirement. I want this to apply to all of my apps. So I've got 200 different applications. They all log in slightly differently. But now, if I wanted to apply the same test to all of them, I'd have to write 200 different tests to be able to deal with all the different login scenarios. The second one is a bit of a technical problem with Selenium in that the Selenium folks are geared towards driving the browser itself. So through their API, they don't expose HTTP at all. Getting the cookie is as low level as you can get with the Selenium API. You can't even get the HTTP response code using Selenium. You can't read HTTP headers. And all of those are quite critical things for security tests. And then from a DevOps point of view, if we wanted this test to apply for our DevOps team, that means we want our developers to understand it, our QA people to understand it, our operations team, our security guys, and even the project manager. That's the whole concept behind DevOps, is we want the whole team to collaborate and work on the same problem. And unfortunately, this is only understandable by whoever understands JUnit and Java. So it excludes a large part of our team. And solving some of those issues was the idea behind the BDD security framework. So it's an open source framework you can download from GitHub. It has a couple of features, most important of which is that the tests are written in a natural language. They're not written in code, which means everybody can understand the tests. It includes automated functional tests, non-functional tests. It wraps security scanners in tests. Currently, ZAP supported, Nessus, and as a simple port scanner built in. This is that same test written in BDD security, in English, basically. The only requirements are to use a given, when, and then format when you write your specification. So we issue a new session ID after authentication, and given the login page, means the browser goes and gets the login page, and the value of the session cookie is noted when the default user logs in with the credentials from this text file, and the user is logged in, then the value of the session cookie issued after authentication should be different from that of the previously noted session ID. So this is understandable by whoever understands HTTP and cookies can understand what this specification is. Each one of these lines is backed by code. So there's code at the back that's running the appropriate bit of functionality to verify this, which means this whole thing is executable. So now we have a real good substitute for specifications in a document written in English. We now have the same specifications. We can write them in English, but at the same time, they're executable. And the other important thing is that you would write this before you build your app. It's a specification. It's a requirement. So the first time the developers realize they need to change session IDs after login is not when they get their scan results. It's before they start building the app, so they can build it right from the start. So a bit more about the framework. It uses Selenium, which means it can use lots of the Selenium drivers. It can use Chrome, Firefox at the moment, Safari, even iOS, Safari as well. And it uses OWASP ZAP. So OWASP ZAP forms the cornerstone of the framework because we can't get HTTP information from Selenium, so we pass everything through ZAP, and we can read HTTP traffic through ZAP. And of course, we also use ZAP to do the scanning. So tests must be understandable, written in English. It fits into a development workflow. So you can run the test in an IDE, you can run them in the command line, you can run them on your continuous integration server so that they run every time new code is uploaded to a CI server. And then the output is also interchangeable. It produces JUnit output. So your other tools that depend on JUnit can just read those results. And it also produces HTML output. Then the logic of the tests is independent from the navigation code. So this was one of the goals, right? We want to use the same set of tests against different applications. And we just want to change the navigation logic in one place. We don't want to have to go and change the tests. So by doing that, the framework ships with a bunch of pre-written security requirements, kind of like a middle-of-the-road, basic set of security requirements for every app. Comes with the framework. You just need to tell the framework how to navigate your application. So let me show you how this works. So the app I'm going to test is a very basic app. Log in with Bob, password, and you can view your tasks in this app. Click on your tasks. You can view your profile, and that's about it. So very simple, but it supports login, it supports log out, and supports doing something behind the login. So if we wanted to test this using the BDD security framework, first thing you would do is check out the framework. It comes in this format. You'll get all the code for the Java bits as well as the stories. And these are the pre-written security stories that come with the framework. So yeah, in JBehave lingo, a story is like a test suite, and a scenario is a test. So a story contains a load of scenarios. You can either run individual scenarios, or you can run whole stories or entire groups of stories. So if we look at the first one, which is AppScan, and this is simply wrapping ZAP in a testing format. So we're going to use ZAP to do scanning. If we look at the first one, SQL injection scanning. The given when then is there, as we saw with the previous example. The complication here is that we have a given story. You'll see it at the start there, under the meta, there's a given story of navigate app. So we're saying, given story says, go and run this story before you go and run this particular scanning. And what we're trying to do here is we want to navigate the application before we go and scan it. So let's have a look at navigate app. Navigate app says, given a new Zap scanning session, and the page flow described in this method is run through a proxy, and the following URL regular expressions are excluded from the spider. So we can add expressions here to exclude from the spider. It's just a text file. We can configure the spider, maximum depth of 5, 10 concurrent threads, and we want to scan these particular URLs. So the base URL is something that's configured in the configuration file, which I'll show in a second. So after we've done that, after we've navigated the app, we can then start doing our scanning. The scanner says, given a scanner with all the policies disabled and the SQL injection policy is enabled, we set the attack strength to high and the alert threshold to medium. So each of these is backed by Java, and I can go to each of these. And you can see that the attack strength, for example, is using a parameter here. So we can pass in the attack strength using this JBehave format. So we can change this to medium, for example. So from a DevOps point of view, you don't have to be a Java developer to be able to configure how you want Zap to work. You can just change it in the specification. Then we'll run the scanner. Next, we will then look at the false positives described in this text file, and we'll remove them from the results. And then we would expect that no medium or higher risk vulnerabilities should be present. So what we've done in these two lines is we've asserted our expectation. So now that process that was stuck in a human operator's mind saying, ignore these false positives and stop the build if there's a high risk vulnerability, we've now coded that up in a document that's self-verifying. So the false positives table is just a text file. It's, again, you would add the URL of the false positive here, and you just use a pipe symbol to put the parameter, another pipe symbol, the CWE ID, for example, like that. And you would add your false positives there that you want Zap to ignore. Right, so that's an app scan. You'd also have to configure a config file. This config file says, we're going to use two Selenium drivers to test our application. One of them is going to use Zap for the tests that require access to HTTP, and one of them is not going to use Zap because it's going to be a bit faster, and we don't need HTTP for some of the tests. So we just define which drivers to use. In this case, I'm using Chrome for Mac. You can use Firefox as well. We define the base URL for our application, so just the common URL from which all the other URLs are based off of. And then, importantly, we define the class that contains our navigation logic. So all our navigation logic about how our app works goes into this class called OWASP demo, which doesn't exist yet. So let me just make a copy of that. Okay, we then define some other things, where the session ID is stored. We define at least 2 users from every role in the app. So we tell the framework who the users are. There's Alice, what her password is, Bob, and admin. So before we can run any of our tests, we now need to go and create that navigation class. We extend web application base class, which provides us with Selenium and some other convenience methods. And if you'll remember, the navigate app story required a method called navigate, which told us how to navigate our app. So we'll create a navigate method like that. And now to just do some basic navigation in the app, we need to give it valid Selenium. And because we want to save time, we'll use the Selenium Firefox IDE, which will record our activities on the app and convert them into Selenium commands, and we can copy and paste them into the file. So if I just want to do login as Bob, password, login. I'll keep it simple for now. So Selenium IDE has recorded those. And as long as you set your clipboard format to Java JUnit 4, you'll be copying valid Java here. So I've copied that, paste, and I've got valid navigation code there. Just need to change this base URL. Done. So at least now we will go, when we run this, the scan, it'll first spider by doing this, run the spider, then run the scanner, and give us our results. So let's run that story, app scan. We can run this individual scenario from the IDE. So it starts up and it starts 2 browsers. Ooh. It's one for you, Simon. Right, so also in the config file, don't know if you saw that, there's the proxy address for Zap. So if we tell the framework where Zap is running, I've got Zap running in the background at the moment, listening on port 888 with a fresh new bug-free instance. And let's try run that again. There we go. So you can see it's running some of the tests in this browser. It's logged in. And we'll see now it's already run the spider, and it's now running the scan. Scan is done. And we have a test failure. We expected 0 medium risk vulnerabilities, but we got 1. Here's SQL injection in this particular URL, in this particular parameter, and this is the CWE ID. So if you manually verified this was a false positive, you can take this data, stick it into the false positives file, and now you won't be alerted with this for future tests. Okay, so that's the first type of security test we want to run, is just wrapping a scanner, and we do the same thing for Nessus. Right? So we log into Nessus. We use a particular policy that's already been defined. We define our targets. We can add them here in text to the story. Run the scanner, remove false positives, and then set our expectation that we want no severity 2 or 3 or so many higher vulnerabilities. And the same thing for port scanning. And we'll use the same approach for any other security tool we want to pull in. Just wrap it in a test, put the false positives in, and we can run that scanner. Right, so that's scanning. That's one type of thing we want to test. We also want to test functional security. So things like test that passwords are case sensitive. Test that the login form is presented over an HTTPS connection. Test that a captcha is displayed on so many authentication attempts. Or test that the user account is logged out after so many, or locked out after so many failed authentication attempts, and so on. So we've got a couple of authentication stories. We also have some session management stories which do similar kind of things. When I log out of the app, I want actually to be logged out. I don't just want the cookie to be removed. It must be logged out on the server side. So these are, again, functional security things I want the framework to test. So in order to test these, we need to do a bit more work, because we need to tell the framework how to log in. Although we've told it how to navigate, and navigate happens to be logging in here, we need to tell it explicitly how to log in and how to log out. So it's got some predefined interfaces. I log in and I log out. Which require us to implement these methods. So firstly, we need to tell it how to open the login page. We've already done that. We'll use that. We need to tell it how to log in. Well, you'd just do that. And we want to log in with any set of arbitrary credentials. So user pass credentials. get username and get password. So now we can log in with the framework, and the framework already knows who the users are because we configured that in the config file. So now we can log in as any arbitrary user. Is logged in is an important method. We need to tell the framework how does it determine whether a user is logged in or not. So this is something you would have to test out of band with the framework and work out. In this case, if you got this URL, for example, the task list URL, when we see the word welcome, we know that we're logged in. If we don't see the word welcome, we know we're not. So we can use that to write our isLoggedIn method. Driver.get get that URL, and if driver.get the page source contains the string welcome, then return true, else return false. And finally, tell it how to log out. In this case, it's quite easy. It's just a single URL we need to get. Let me just verify that. Yeah, user logout. Good. Right. So now the framework knows how to do a lot more things. Our navigate method becomes simpler. Open the login page and log in using any set of credentials. And now we can run things like the authentication story. Fires up the two browser instances and runs Selenium tests against them. Done. And we have our results. We can either read them in the IDE or we can read them in HTML. So here we can see which of our requirements have failed. Passwords happen to not be case sensitive here. The login form is not presented over an HTTPS connection. It should have, we expected HTTPS, we got HTTP, and so on. And the user account was not locked out after 4 incorrect authentication attempts. Right, so there are many more functional and then also non-functional security requirements defined. So we have things like HTTP headers. Verify that our app is using the right security headers. Do we have strict transport security enabled? Do we have anti-MIME sniffing header inserted? And we have SSL, for example, test for heartbleed, test that we support TLS 1.2, et cetera, et cetera. So again, the difference between verification and tests is that these tests you would give to your ops guys and say, build me a server that meets these requirements. And they build it like that, not get the results after they've built the server. Right, so I think one of the more interesting types of tests or functional security tests you want to run is access control. You want to test that Bob can't see Alice's data, right? And that's something that scanners typically aren't really good at finding because they don't have that conceptual knowledge of the application. But we can program the framework to understand that. So with our app, for example, every user has a profile. And they should, of course, only be able to view their own profile. So to configure an access control test, the framework requires 3 things. The subject, who's logging in this case, Bob. The action that Bob performs, in this case, view his profile. And then the sensitive data that he sees when he views his profile. So we can pick one bit of data there that's unique to Bob and make sure that no other user can see it. So we configure this again in the navigation class. We create an arbitrary method name. We'll call it view Bob's profile. And we will get the base URL So we'll get this page, and then we'll click on the profile link. How does Selenium click on links? Well, we can just record it. Click. That's what a link click on profile looks like. And that's it. So we've defined one of those three. We've defined the action we perform. And now using an annotation, we tell the framework who is allowed to perform this action. In this case, only Bob. It accepts an array here, so you can put other users who are also meant to see the same data. And we specify the sensitive data that only Bob should see when he clicks on that link. So let's just pick his first name, Robert. Okay. So the framework now has everything it needs to perform an access control test. It knows how to log in. It knows what action to perform in Selenium. And it knows who the other users are of the app. It's user Bob, Alice, and admin that we've configured. So we can run the authorization story. And it's running its tests. And done. So the access control story is a bit unique in that the very first scenario is this kind of a setup scenario. So the first time it runs, it goes and first checks that what we've configured is correct. It creates an access control matrix automatically from the data that says when user Bob logs in with password and he performs the action view Bob's profile, then he should see the sensitive data somewhere in the HTTP responses. So that should always pass if we've configured everything correctly. And then it builds the inverse access control matrix. So it says, if user Alice logs in and then performs the view Bob's profile action, she should not see the word Robert in the responses. And it goes and recreates the scenario for each of the users that has been defined in the config file. So we can automatically test for access control. And we can see in this case, we have an access control failure in that Alice can see the word Robert if she performs the action view Bob's profile. And as a human tester, we can see this is one of those basic access control problems. There's just a parameter there that any user can see any other user's data by changing the parameter. But the framework went and found that for us. Right. So since we're using standard technologies here, we can run from the IDE, we can run from the command line, and in a good example or in a good practice scenario, we would also want to run this on our continuous integration server. So this is from the point of view of a developer changing a web application with integrated with Jenkins and integrated with BDD security. So the developer goes and changes some code. Say he's changing something in the web application. It's a Grails web app. Changing how to do queries, changing how to get the user ID. So the developer then goes and commits his code to Git. So in Jenkins, we have two jobs. The first job is the ropey tasks job, which is to build the web application. So the first job is continually monitoring Git. And if anybody submits new code, it goes and pulls down the code, builds the application, and deploys it onto a test server. The second task, it then checks whether the first is finished. Once it's finished, it's going to go run the BDD security tests against the deployed application. So all of this is entirely automated. I'll be clicking around on the screen just to show you what's going on in the background, but this doesn't require any user interaction whatsoever. So here we see it's building the web application itself and deploying it to Tomcat. So it's deployed, and now it calls the next task, which is to run the BDD security tests. And in this case, they're running on a Linux box that has X enabled and an actual browser, but you can run them headless. You can run Zap headless as well, so you don't need to actually run a proper browser. This is massively speeded up. It doesn't scan this fast. So running all the non-functional, functional tests that are included, all of the stories.
How long will it actually take for it to run?
So for this simple app, it takes about 5 minutes.
Like in a realistic scenario?
Yeah. But remember, this app's quite simple. There's only like one form to scan, so it's, the more complex your app. The big bottleneck's going to be Zap scanning. So typically, as fast as you can do Zap scanning, you would do this type of scanning. So we get a report immediately of our test results. We have 24 failures in total, and 3 of those are new failures caused by the new code commit. And we can see what they are, and Jenkins will take us, give us more information about those failures. Since they are JUnit results, we can get the same message that we do from the IDE. We found a cross-site scripting vulnerability. We found an authorization vulnerability, an access control flaw. And because Jenkins integrates nicely with GitHub, and we happen to be using GitHub, we can go directly to the code that caused this problem. And we can see which commits have caused these new 3 failures. And we can look at the plain HTML reports as well from within Jenkins if we wanted more detail about exactly where the problem was. Where is that cross-site scripting vulnerability? Right, so there are some limitations. The access control tests, for example, are not CSRF aware or anti-CSRF aware. So if you've got CSRF tokens in your app, it's not going to be able to do the automated access control tests. That's something I'll be looking to add quite soon. Email actions are not implemented. So if you want to automate self-registration or unlocking that requires email, you can't do that at the moment. You have to write that yourself. Yeah, test maintenance. Because we're relying a lot on how we're navigating the app, it's a really good idea to put logical tests in your navigation code that fail if you see a page you're not expecting to see. So if in your navigation code you're getting to a page that you're not meant to get to, assert a failure there, say something is wrong, so that the test fails and you know you need to change something, rather than just having it silently continue and you get false results. So what we've done is we've moved from this model where we're using dead documents as the central part of our security architecture, and we're moving to live self-verifying requirements. We have requirements that can verify themselves. We can run them at any point and say, what is the security of our application looking like? And it can tell us what fails and what is passing. We still have these processes, but now they're wrapped in tests, so we can run them whenever we like. It doesn't cost us anything. And we have documented what our false positives are and what our acceptance criteria for each of those tools is. Some references. So some additional tools that you could strip out from the framework if you're just interested in doing specific things. I do want to mention 2 other frameworks that are quite similar to this. Gauntlet, which is written in Ruby, and it's purely a test wrapper. So it wraps Nmap and it wraps a couple of scanners. It doesn't do any functional tests. And then Mitten, which is recently released by AppSecEU, is written in Python, and it uses burp to do a similar type of thing. Again, it's purely scanning. It's not doing any functional, non-functional tests. Guess we have time for questions? Sort of? 1, 2? Yes. Okay, 1 question. No? Okay, if you have some, I will be available after. Thank you.